Assalamualaikum and hi guys, this is 7.2 part 1. So 7.2 is about acid-base titration. Here are the learning outcomes. At the end of this lesson, students should be able to A. Describe the titration process. Next, B. Distinguish between the endpoint and equivalence point. So, are you ready? Let's go! Acid-base titration. Have you ever heard of acid-base titration? You're going to encounter a lot, right, in this semester. Even our practical test is also on acid-base titration. So here is the basic build-up of the titration apparatus. So what's meant by titration? Titration is a process where the solution of accurately known concentration, which is known as titrant, is added gradually to a known volume of solution of unknown concentration, also known as analyte, until the chemical reaction, which is the neutralization reaction between the two solutions, is complete. So this is the titrant, right, which is the solution of accurately known concentration added gradually. That's mean we're going to add it slowly, okay, into the solution of unknown concentration, which is the analyte. So after the usually, right, the reaction that is involved is neutralization between an acid and a base. Sometimes the acid can be the titrant, or the acid can also be the analyte, or vice versa, right? Doesn't matter. Just you need to look at the question carefully, whether the acid or the base has become the analyte. Okay. So next here is the titration apparatus. Right, we can see here that we are going to use the retort stand, and then we are going to use the white paper or white tile here, right, the big white tile, and then the retort stand is clamped to the burette. So the burette here, okay, consists of solution of known concentration, which is known as titrant. This is the titrant here, whether acid or a base, it doesn't matter. For example, in this our example, we have an AOH solution, which is the base. So the base is going to be the titrant, and then the analyte, we fill in the analyte inside the conical flask. So the analyte is solution of unknown concentration. Right, so by titrating with the solution of known concentration, we can calculate the concentration of this analyte. And then what is the uses of this pipette? This pipette is used to pipette the analyte into the conical flask. Okay. And then we also have indicator. This is very important, right? For example, here indicator we have phenolphthalein, right? It not necessarily be phenolphthalein. You must use the suitable indicator according to your type of neutralization. Right, so this is the basic build-up. So this is the build-up of the titration apparatus, right? You must use a retort stand, clamp to it to a burette, and then inside the solution inside the conical flask must be transferred by using the pipette with a high accuracy. And then inside the analyte, you must add on the indicator, suitable indicator. Right, for example, now analyte we have sulfuric acid, right? Then we add the phenolphthalein indicator. So for this example, we are using the strong acid and strong base. Next, equivalent point versus an endpoint. So you need to be able to distinguish between equivalence and endpoint. So what's meant by the equivalence point? The equivalence point is the point at which the amount of acid and base present exactly neutralize one another. Or in other words, we can say that the number of moles of hydroxide ions and the number of moles of H+ ions are equal. Right? So we know that we need to stop the titration when the reaction has completed. That means when the acid and base neutralize one another. But then how do we know? We can when doing the experiment, we can't see with our bare eyes. The equivalent point usually we can we know the equivalent point by using the calculation. But then how do we know when we are conducting the experiment? How do you know when to stop? So we need to use the indicator. So the endpoint of titration is the point when the indicator changes color. So here come to rescue. That means the endpoint is the point when we know where to stop the action. When you see the changes, when you do the experiment, you need to observe, right? So when you see the changes in color of the indicator, then you know it's the time to stop, right? So that is called the endpoint. Endpoint is the point when the indicator changes color. For example, in this titration, we use the phenolphthalein, so we can see that this is before the endpoint initially, and then this is at the endpoint, faint pink, and it is there after endpoint. That means that this is the overshot. So we need to get this point. Okay, this is the endpoint. When you get the faint pink, this is when we use the phenolphthalein. When you get the faint pink or pale pink, you need to stop, because it indicates that you have reached your equivalent point. Right? So, are you able to distinguish it? Yes.